Well, welcome back, everybody. It's our weekly live stream again, and my name is Craig Maynard. I'm a first senior mentor for FIRST Robotics and a huge robotics and FIRST Robotics enthusiast, just like you guys. And I got with me my colleague, Max, the other senior mentor. You there, Max?
I am here.
Fantastic. So as promised, today we're going to be introducing you guys or showing you guys a little bit about Solidworks. Now, Solidworks is a huge program. If you look at it, it's got a great logo over there. But Solidworks is a huge program. This was one course that I took, and this was the quick reference manual for Solidworks. That doesn't mean you have to be scared of it. That just means you have to understand that it's going to take a little bit of training to really master this course. At SAIT, I teach a Solidworks course to our mechanical engineering and technology students, and it's 6 hours a week for 15 weeks, and then we start to get pretty good at it by then. But that doesn't mean you can't do a lot of very exciting stuff with Solidworks in your team. And the wonderful thing is you have Solidworks provided for you. That's a very, very expensive application. And Solidworks and the FIRST community has created hundreds and hundreds of parts. They've actually simulated your entire kit of parts. So what I'm going to do today is we're going to do a little tour of the kit of parts, and we're going to see if we can do some simple modeling. We're going to take some parts and place it on a board. We're going to look at the chassis and how the chassis works. We're going to try to do some assembly connections, some mating some components. So if I'm going a little fast, it's because there's just so much to learn. Anyways, let's move ahead here. What you can see here is the main desktop for Solidworks. Now, before I go into Solidworks, I think we should probably have a look at some of the resources that are available. So I'll just bring up, this is the main Solidworks page right now. If you go to blogs.solidworks.com, you'll notice they've actually got, or if you search for FIRST Robotics Solidworks, you come to a page like this, which describes everything you need to know about loading the Solidworks and how to add folders and how to browse your FRC Solidworks kit of parts. All of this stuff is all included right here. Now, more interestingly, if you go to www.solidworks.com and look for the FIRST Robotics kit of parts, you'll see all of the kit of parts are available for you for download from that site. You can see there's the drive base kit. We have the yellow tote, the gray tote for 2017. That even includes the game components like the pellets and the gears and things like that. And it goes back. There's 2016 kit of parts. There's a 2015 and 2014 and older. And then there's all kinds of Solidworks tutorials down here. So Solidworks tutorials all exist at the bottom, and then more resources. If you're in FTC, they have FTC kit of parts too, so all those parts are there. And if you look way at the bottom, there's the Lego Technics. You can actually do your Lego robots as a kit of parts in Solidworks. So it's a very, very incredible resource for you right on the solidworks.com page. So the whole URL, if you can't read it, then that little text is www.solidworks.com/sw/education/student-design-contest.html. All right, now at this point, I'm going to assume that you've actually downloaded Solidworks. You've got the license installed now, and everything should be ready to go. The Solidworks logo looks just like that right there. You double click on that, and what you're going to get is the main Solidworks page. This page right here is going to be our entry point. Now, if you go to File, you can open up a new part. So let's just go to New right here, and you notice there's three selections. There's the part, and that's the individual component. That's a single piece, a gear, a piece of rubber, a bezel, a bearing. Or you could have an assembly. Now, assembly is a grouping of parts, so all the individual parts can be put together in the assembly. For instance, if one part was a wheel, you could bring in 6 wheels, all the same part, into an assembly and then attach it onto your frame and make your robot able to rule around. There's drawings. Now, drawings will give you a two-dimensional sketch of an engineering drawing of your actual part. So if you want to print out the your robot design in top, side, or orthographic view, or whatever you want. That's what the drawing's all about. And best of all, right at the bottom here, Solidworks Tutorials. Okay, it's all waiting for you there, guys. You just log in, you start at the basic part drawings and how to fully realize a component, and you just move through those one step at a time. It's a great experience, and there's a lot of requirements out there in industry for people who understand computer-aided drafting and CAD programming, such as SolidWorks or AutoCAD. Anyways, let's go in here, and we're just going to create a part just for simplicity's sake, and I'm not going to go into too much detail on how this works. All these menus, of course, that's going to be what you guys will have to learn as you go through the tutorial. But let me go through a basic sketch. So I'm going to show you how that would be done. I'll sort of, if I can talk you to it. Now these are the three planes, front, right, and top plane that we can sketch on. So let's say I wanted to make a control board that I'm going to put my components on top of my robot. So I'll just go into my top plane, and I'm going to choose Sketch, or I can go up to here and I can choose Sketch. So top plane, we're going to sketch on there. It goes normal to the top plane, and let's say we'll just put a rectangle up here. Let's make a 3-point corner rectangle. So I'm going to go and I'm going to draw a rectangle like that, and here we have our basic rectangle. I can hold the scroll wheel down while I'm moving the mouse, and I can actually see my two-dimensional sketch. And I like that sketch, but it's just 2 dimensions. I want to kind of fill it out a little bit. So I'm going to now go to Features, and let's extrude that sucker. Well, actually, before I extrude it, maybe the best thing to do would be give it some dimensions. Okay, because we got no dimensions on here. So I'm going to go back to Sketch, and we're going to Smart Dimension it. We click on Smart Dimension, and I'm going to tell it, let's Smart Dimension this side. I want to make it, let's say 60 inches. It'll be 60 inches across, and the width here, I'm going to make it 40 inches. Okay. And there we go. It's a 60-inch by 40-inch two-dimensional plane. And this is the origin. This is the 000 reference point for SolidWorks right now. And it might be nice to actually tie this into an origin. Now, if you look down here in the corner, there's something that says underdefined. And it's saying that because it doesn't know where this plate lies with relation to origin. I haven't actually defined it. So maybe I should define it just to get rid of my under definition. So I'll just choose my sketch again. You'll edit the sketch, and I'm going to choose this part and that part, and I'm going to add what's called a relationship. I'm going to make them coincident like that, and now you see the origin has snapped right to the corner of my square, and it now says fully defined down here at the bottom, right? Oops, right there. I can never get used to the cameras. Oh well, right down here at the bottom it says fully defined, so I'm good. Bravo. So I'm going to save that. Now, let's extrude that sketch to make a 3-dimensional object out of this. So I'm going to take this and let's extrude it by, let's say 1 inch. We'll make it 1 inch thick. Now you see our object has got some depth to it. Maybe to exaggerate that, I'll make it 3 inches thick. See, we've got some depth to our object. So now we have a nice plate. That could be our control panel that we're going to put our parts on. Okay. Now, just to make it a little bit more realistic, you can go into properties right here. Let's just say we wanted to make this out of gold. I'm rather partial to gold. So we're going to select gold. And now we have a gold. Oops, didn't quite take. And in a perfect world, we would have had a gold brick. All right. So now we have a part. This is one of thousands of parts that are going to be in your robot. So let's bring in some other parts and make an assembly. So at this point, we're going to make an assembly from this part and add some things to it. So if I go to File, and I'm going to say make assembly from part. You see, you make assembly from part. You click on that, and it says you want to save the file. Well, that's always a good idea. So I'm going to save it as I'm going to call it a plate. Okay. Now I am in an assembly, right? And the first part of the assembly is the plate, and we're going to bring in some other parts of the assembly too. There, oops. So there's my plate in the assembly. Now let's insert some more components. So if you move up to Insert Components, you'll find it's now coming up with this window that says Parts and Assembly to Insert. And to do that, you browse. So what you do now is you move to all your kit of parts in SolidWorks. Now, what I did earlier on today was I went to this SolidWorks page right here, and I downloaded all of these guys. They're all in zip format. I downloaded them to a convenient place, and I unzipped them. I extracted them all, so they show up. And now in SolidWorks, you can see there are the folders all ready to go. So let's start by looking inside our yellow tote and see what SolidWorks has got for us. Okay, now I've chosen the extra large icons here so we can actually see them. And you can see we got everything. There's our compressor, there's our corner bracket. We have the plugs, we have the pneumatic control module, power distribution. Everything's there. There's your voltage regulator and your spark motor controller, your solenoid valve on your pneumatics. So all of the elements are here. So let's start with the power distribution module. So I'm going to click on that, and I'm going to say open. And if all works well, you get a little bit of a thought process going on. We see our power distribution module is now shown up, and you see it's kind of floating in space. It doesn't know exactly where it's living. Now I do think that this panel that I built was pretty big. You notice compared to that power distribution module, this is probably a little bit too big. So maybe I'm going to resize it. How will I do that? Well, I'm going to go back to the plate, and I'm going to go back to the Boss Extrude sketch, and I'm going to edit that sketch. Save the assembly. Saving it as an older version. And I'm going to make the numbers a little smaller. Let's say instead of 40, I'm going to make this 10. Oops, that didn't come out the way we planned it. Let's make it 15 inches, please. Thank you. By 30 inches. That's a little more reasonable. And then we'll save that. Okay, now we're going to head back to the assembly. Power distribution. Oh, that's the power distribution board by itself. So now we're going to go back to our assembly. So I'll just minimize that, and we're going to go back to our assembly window, which is right here. Ooh, where's my oh, that's the other part. I'm sorry. That's the plate. That was the other part that we built. We want to go to the assembly window. So the assembly window is there's the plate, there's the part in assembly. And I'm just going to bring open the assembly. So here's the assembly now. And you notice I've resized the part, and the assembly shows the new size. Now I want to put this power distribution module. Let's have a look at it. Oh, it's in Wireframe right now. I do this sometimes when the processor starts to bog down. I view the part in Wireframe to reduce the lag. But let's make it pretty. Let's go to a full 3D rendered model. Come on, you. It's being grumpy with me today. Oh, Lordy. So we're not showing up the way we want to show. If I select it, it should show as a full 3D rendered model, but it's showing up as a wireframe for some reason. I'm not exactly sure why that is. Oh, maybe I know why. That's why. I believe it's because the objects were hidden. There it is. Thank you very much. Okay, now we got to put this onto that plate. The way to do that is we're going to do something called mate. So we're having little problems here. I'm not in the proper sketch. Oh dear, I knew this would happen if I didn't rehearse this. Let's just save all that. And we're going to go back to our plate. I'm going to go back to my plate. I'm going to go File, Make an Assembly from the part. I'm going to go here. We're going to bring in the panel one more time. And we're going to open that up. And we're going to say, yes, sir. And there is someplace there. Here's where I want to be. Okay, so now you see we have, finally, we have the two parts. That's what happens when you go off script. All right, we're going to mate these two together. So to do that, you click on the mate option right here. And in this little box on the side here asks you what you're going to mate. So in this case, I want to mate this surface right here, and you notice it shows up at the top with, and I use my thumb wheel to scroll down, with this surface. So now you see there's two surfaces show up, and the object is now mated on that. You see how it's actually lined up on that surface? I'll click on the arrow here, and that tells me that I'm going to accept this. There we go. And now you can see this part here can slide around on the surface of this thing. Oh, did it mate? But shouldn't be able to leave it. He said, as the part disappears into the ether. I'm going to try that one more time. I'm going to get rid of my mate here. I'm going to delete this mate because it didn't seem to stick that time. So I'm just going to delete that mate. Yes. And we're going to try this one more time. Minimize that. Okay, now one more time. I'm going to bring this thing a little bit closer to the object itself, and we're going to mate this surface right here with this surface right there. The two surfaces show up. I choose yes. And now we see the parts are actually attached. And I say yes. And now, in theory, the parts should be mated together. Okay, see how it's actually stuck on the top of the surface. And we can bring in as many parts as we want. So if I go to back to my browser and we move on, let's say we want to bring in a pneumatic control module. We can open that up and I'll just place it there. We'll set up a new mate, click on mate, choose this surface, and it shows up in the menu there. And we'll choose that surface there. So those two surfaces are there and we want to make them coincident. And we say yes. And now the two parts are on the board. Okay. So these parts, and of course I've only got them mated horizontally. So if I take the parts and move them around, you see, I can move them flat on the surface, but I can't lift them up and down. I can only move them forward and backwards, right, on that actual surface itself. But doing this allows me to add in all the parts that I want to from my kit of parts. And we have a lot of stuff in the kit of parts. Let me show you a few of the things we can see in there. I'm just going to minimize this, and let's go File and Open. So if you can look at your kit of parts, you can see you've got your battery tray and all the components for the battery tray in there. We have, and if we go back to the FRC kit of parts, we can go into the long frame or the square frame or the wide frame chassis. So let's go into the long frame chassis. And you can see all the parts for your chassis show up there. Every gear, every bezel, every bearing, every structure you want to have is waiting for you right in there. Okay. So let's go to the wide frame chassis right here. And the cool thing is, if you wanted to, someplace in here we even have the completed chassis. So if you want to start with the base chassis, which already exists, you can go directly there. Let's see here, extra large. Where is it? No, I saw it there. It was there when I was looking at it this morning. Isn't that interesting? Chassis seems to have eluded me. You know, the best part about this, Max, is this all goes out live. All right. I'm just going to have one quick peek in here to see if the chassis exists. Oh, it doesn't. Okay, but it is there someplace, and perhaps I've done something to nuke it. Field. Also, in addition to all the kit of parts, the gray tote, the yellow tote, and all the different kinds of chassis configurations, they have the actual field here too. You know, I think the problem is I'm looking for an assembly. Maybe I should be looking for an assembly. There it is. That was the problem. I was looking for parts in SolidWorks, and it showed me the individual parts. I should have been looking for the assemblies. So I actually chose the assembly right here, and there's the example of the SolidWorks chassis. Okay. So you see it's all ready to go, so you can actually put your panel on top of that, and you can start to mount your components on there. Your chassis, ready to go. All right. Anyways, let's put the chassis down. Let's try some tricks with the with assembly again. So I'm gonna set this down. I'm gonna put this down to all the work we've been doing, all that hard work. Let's go in here and let's open up a part. Let's go to parts and let's find ourselves a sim motor. So I believe I saw the sim motors in I believe it's the gray tote. Let's have a look in there. Look, there's the bag motor. There's the sim motor, a whole bunch of fuses. So we'll choose a sim motor, and you can see it there waiting for us, all ready to go. Okay. Now let's make an assembly. I'd like to take that sim motor, and I want to put that sim motor on a gearbox, let's say. Okay. So what we'll do is we're going to make an assembly from this part. Okay, and it says, what do you want to add in? Well, I'll just browse around, see what I want to add in. Okay, can't see my gearbox there. Let's go back to my other tote. Let's try the yellow tote out. Wander in there. And it's not in there. I believe we're going to find it in the chassis. So let's go to the long frame chassis. Go inside there. Start checking it out. And there's the Tough Box Mini right there. So let's, and this is all the pieces if you want to put it together yourself, but here's the actual assembly all ready to go. So let's open up that Tough Box Mini. You see it shows up down there in the corner. And I think it's there. Is it still loading? Probably still loading. Oops, we'll say yes. There we go. So there is the, there's the motor. and it's asking me to save the modified document. So we'll just save it. Thank you very much. And this is good. This is what happens with SolidWorks sometimes. And this is what happens when you live stream all the time. So let's just reset this thing, and we'll just launch SolidWorks one more time real fast. It's always easier the second time. Somebody must have divided by 0 someplace in there. Ah, here we go. Okay, so back to our program here. There's the ToughBox Mini, and there's a sim motor. Well, let me open up the sim motor one more time, and we'll try this from scratch. We're opening up a part of the sim motor. Great. We're going to make an assembly from the part. And add on the gearbox, which we have already found in the kit of parts, long frame chassis, somewhere in there. Oh, look at all those parts. ToughBox Mini, there it is. Give it a second to load in. And my gearbox should be loading in. It says down here in the properties that I have the sim motor. It says I haven't got a gearbox. Oh, isn't that sweet? I'm just going to look to see if it's on a different page here. No. Window, assembly 1. There's my assembly 1. And do I see a gearbox on there? I do not. There's no gearbox on the right side here. So, well, let's try again. Insert components, browse. I wonder if there's some corruption going on in this little gearbox. ToughBox Mini. Yeah, thank you. And it says, where do you want to put it? I'm just going to put it in space right there. And there we have our tube. Wasn't that easy? You just have to do it 4 or 5 times. Now, question is, how are we going to mate these guys? Now, in this case, this shaft right here on the end of the robot, on the end of the sim motor, is going to plunk itself right into that little hole right about there. Okay. So how do we do that? Well, we go to mate again, and it says, what do you want to mate for your first surface? Well, in this case, I'm going to choose the shaft as my first surface, and there it shows up there. Now for my second mating, I'm going to look inside this hole, and I'm going to try to mate it to the inside of that dimension. So I've actually mated it to the inside of the hole, and that's great. So if I say yes, now I got my motor, and I can just close that up. Now the motor is now mated inside the hole. Okay, now unfortunately I've got 2 holes here I have to take care of with 2 motors. Is that you falling off your chair, Max?
Yes, I'm sorry.
That's okay. All right, so I hold the control key down, and I'm going to click on the motor and drag with the control key, and voila, I have a second motor. It's way easier than having to order anything from Andy Marks or Studica. Just the control key and drag. And again, we're going to do a mate. We're going to mate from this object. Oops, that's a very unusual mating. I don't think that's probably what I had in mind here. Let's do it again. So we go mate from this shaft to the inside of that, like that. And we say yes. And now we have 2. Now, this is a little unusual. You might notice one motor standing a little proud. So if I grab that, you can actually see It's going in the hole all right, but it isn't totally defined. Unlike the other side, I've mated it on the shaft, but all of these, but it being a concentric mating, these are all valid, right? I can't move it left or right, up and down, but I can move it in and out. So to fix that, I'm going to have to set up another mating. So and to do that, I'm going to mate this surface right here with this surface right here. And I say, okay. Oh, I'm going to make them coincident. Yeah, it doesn't like that. Delete that, delete that. We'll try that one more time. I'm going to make this surface with this surface. There, like that. And I'm going to make them coincident. That means that they have to touch each other. And I'm going to say yes. And now I've got my second motor attached onto my sim box. So mating is very important. It's a very important concept to learn when you're trying to build an assembly. But the beautiful thing is most of the parts you need for your robot are actually already built in the kit of parts. So you can just bring them in and fumble through it as I did, hopefully going through a series of tutorials first before you actually build this, get used to creating these assemblies right now. But I tell you, once you do get used to it, it's a very, very powerful tool. You can create your entire robot on Solidworks if you want to, right down to the wires, the electrical connections, the framing, everything. All the extruded aluminum from Fastech or from Rexroth or whoever makes extruded aluminum, that's all available in Solidworks too. So you can pretty much build your whole robot, and the better groups actually do. In fact, sometimes they'll have several models of potential robots already designed, already kind of laid out in SolidWorks, even before the build season starts, even before they know exactly what the competition is going to be. They may have a little mechanism that they built and say that it's an assembly for a frisbee shooter. They may have another mechanism set up for a small ball shooter, maybe a large ball shooter, or all the standard, projectiles that FIRST likes to know. And you can build them all virtually and see how they work. You can do stress analysis on them. You can make sure parts are going to fit together. And then some of the parts you might have had to make, for instance, you may have to make some steel panels with some holes in them to hold things together. You can take those panels as parts and you can send them off, if they're properly, fully defined. You can send them off to the laser cutters or the water jet cutters, the machine shops, to have them actually cut and made for you. So I know some teams, like 4334, for instance, will do their solid modeling in advance of the build season. And when it comes time, they spend the first week and a half or 2 weeks of their build season working on the virtual model. And then they send the parts out and they come back, and the last 2.5 weeks, they just spend bolting it back together and working the bugs out. So solid modeling, very, very, very powerful tool. And I apologize for the bugs and things like that. But like I say, this is what happens when you do these things live. It happens in my class all the time. In fact, I'm glad I got away with only one crash. Usually it's a lot worse than that. So I don't really want to go too much further in the description of SolidWorks at this point. Did you have anything you want to add, Max?
No, I actually don't. We have no questions yet.
Have you done SolidWorks before?
Actually, I've just played with it very at a high level. So I haven't done anything what you've shown here. Right. And I think I will go out and play with it now.
Oh, you should. It's a lot of fun. As I say, the most difficult thing in SolidWorks to get a properly built model is you got to make sure that it's properly defined. And you can see right here where it says underdefined. This indicates that this thing has some ambiguous dimension somewhere. It doesn't know exactly where it fits in space, either X, Y, or Z. There's some dimension in there that's undocumented. So a professional SolidWorks modeler or a good SolidWorks modeler will make sure that this little text right here says fully defined. That's the cat's meow. Now I've even noticed that some of the parts that come from these sources where we got this kit of parts from aren't fully defined. So but still, it works great. It works great. So I think sometimes we may actually have a SolidWorks class, perhaps an interactive class where we can get a few of you on the computers and we can do some simple models and teach you all about this particular program. This is kind of a program, by the way. This is called Parametric Modeling. That means that everything in the whole model is defined by parameters. You're not so much sketching the thing out as you are setting up a bunch of contingencies, a bunch of relationships, a bunch of dimensions, and you're putting it all together, and it just ends up looking like a motor or a gear. But it's actually a whole number of parameters. And those parameters are quite clearly laid out. You can actually see now as we've created all the elements in SolidWorks right here. You can see things like all of these different parts. You've got a small hex shaft. See all the different parts that are involved in this gearbox. They're all individual parameters, and you can walk into each one of these guys, and you can see every one of these parts is a part on its own right. It's got its own planes. It's got its own origin. It's got a bitmap. Obviously, that picture is kind of an overlay, a bitmap on the thing, and it's got a couple of cut extrudes. All right. So, and this parametric table on the side, this features table, gets to be pretty large after a while. Now, if you find that your system starts to bog down, like mine did, as I said, you can actually switch over to Wireframe, right, like this, and that takes a lot less processing. Work moves a lot faster, and then bring it into a solid model when you're actually ready to look at it in all of its awe and beauty. Okay, well, is there anything else you'd like me to show you in SolidWorks, Max? I'm at your disposal.
No, I think that's good. I think that will get a few teams going so that they understand the basics of assembly, so they can start playing around, so that they will be ready come January 6th.
For the big kickoff.
Absolutely.
I want to show you one more thing. This is kind of cool before we go on. One of the first things you should download from SolidWorks, let's just open up a new assembly here. If you roll back into it, this is the actual field for the competition with all of the individual parts. There's the boiler, and there's the boiler mirrored. There's the little propeller that was on top, some of the hinges, all of the parts. The driver stations and stuff are all laid out in SolidWorks, and somebody actually has the entire field here. Now, just for jollies, I'm going to open up that field, and I probably should, it's actually opening up pretty fast. And so you can see the actual field is all ready to go. You can see the driver station, you can see the flying contraption, all of the fuel cell hoppers are all there. So a person could actually take this, and let's just change the view to a top view here. Oop, that's the end view. That's not a top view. That's a top view. You could actually take this, print it out as a drawing. You could use it as a planning instrument for your strategizing too. You could put up a small version of the robot and move it around and get the relationship between the robot and the field and the game elements to help you design your robot. So it's very cool that the actual field has been given to you in SolidWorks. And I'm sure in this next season's competition power-up, the field is going to be available to you come kickoff as well, right off the bat. And that's another kind of a little cool feature. All we have to do is find a 3D printer as big as a house. We could just print the thing out. All right, any questions show up from our viewing audience out there, Max?
Nope, no questions at all.
Oh, either I baffled them or I just did a fantastic job and there's no questions required.
I think it's the latter.
There you go. Yeah, I love SolidWorks. It's really a lot of fun. I've built a lot of cool things with SolidWorks. This is a for instance, I I had to get a device here for feeding these pucks to my students. So I created this little model right here, right, in SolidWorks. I put the puck in there, and then the pneumatic comes along and kicks it out. And it was a very, very complicated device. It's got all kinds of shapes and angles and things to it, as you can see. And then I just took it and printed it out on our Zortrax 3D printer. Cost me maybe $3 in plastic, and I have the finished piece, no machining required. So there's a lot of odds and ends and brackets and clips and fasteners and things like that. You can build in SolidWorks quickly, print out, and then put them onto your actual robot. So instead of having to machine or create some objects using traditional techniques, you just model them up in SolidWorks and print them out. Or you can do a rough sketch and dimension them properly and then pass them on to maybe a colleague or a team that's quite good at SolidWorks, and they might be able to model it for you. So that's another thing about SolidWorks which I really enjoy. SolidWorks also gives you the options of doing simulations. You can do all kinds of load testing, stress analysis, all kinds of analysis like that to show you where your points of failure are going to be. Fatigue testing. You can put various loads on your parts to see what their breaking points are. Yeah, it's a very, very full-featured package. And to buy this retail, I mean, SolidWorks costs $10,000. It's a very, very expensive package, especially fully equipped, but very powerful and well worth the money. All right, Max. Well, that's pretty much all I've got to say at this point. So that's our little talk on SolidWorks right now. So if you look at our webcast, that was our spooky SolidWorks for beginners, and it was spooky. It crashed once, and I got lost up at that SolidWorks rabbit hole 2 or 3 times. Next week, we're going to look at some basic electronic principles and some wiring. Now, if anybody watches this video offline and you put some comments in the field, or you email Max or myself, it's max@frcwest.com, or Craig, CRAIG, @frcwest.com. Ask us, send us questions and things like that, and we'll be happy to answer them. And if you have any more specific information you'd like to have on the webcast, we can do that too. But our next week is going to be basic electronics and wiring. And the week following that, we're going to be doing a little introduction to Java. So I'm really looking forward to that one. So that's about all I got to say, Max. You got anything else you'd like to add? Any upcoming items? We had a great time at the Makers Fair on Saturday.
Absolutely. And met a lot of people and got a lot of interest from individuals that want to join teams, but also schools that want to form teams.
Absolutely. Yeah, and all 4, this is the first time we actually been pushing all 4 programs like gangbusters, all the way from junior first Lego League to the first robotics competition. You know, and it's just great that all of these programs have now come together and are offered right across Alberta for all of us. And
just a couple of advanced sales points here. Saturday, November 18th, as FLL Junior and FTC will be at St. Joseph's School in Red Deer, doing invitational, and encourage all those teams that are not there to come out, check out your competition, see what they've done, and get some ideas for your robot. And then we are also having a FRC invitational at SAIT on December 2nd. And we will again have the other programs there to show off what they have, but that is primarily going to be invitational in a different simplified game for the FRC robots.
Fantastic.
And all of this is free for everybody.
Yep. And then it's kickoff. And I can't wait. I can't wait for the kickoff. You know, I'm an 8-bit hacker myself. I cut my teeth on old 8-bit computers like the Ataris and Commodore 64s. And it's nice to see that retro is now chic. And it might even be a competition this year, which is appropriate because it's just a couple of years later than Steamworks, right? Right after the Industrial Revolution, that's when the 8-bit computers came out, I think. So maybe it's a timeline thing. Yeah.
So you can think about next year's then.
That's right.
2019, what would that might bring us?
I don't know. And during our kickoff, just after our kickoff, we're going to have a quick build at SATE. So if you're a rookie team and you want to put together your own chassis and get it running and programmed and get it hooked up to the driver station, we'll have some talent there at SATE to help you do that. And if you're an adult or a mentor or a coach and you'd like, SATE's also going to be having a robot in 3 days. So Dan and I have got all of the components coming in from Studica. They donated a kit of parts and all the things we need to build an FRC robot based on this year's challenge, Power Up. And we're inviting any adults who want to come and join us for that 3 days. We all have pizzas and drinks, and we're just going to have fun building a robot and showing these young pups how it's done in the big leagues. Are you going to come on board, Max? You going to help us out?
Oh yeah, oh no, absolutely.
Okay. Yeah, robot in 3 days is a lot of fun. And we'll live stream that for you too, and hopefully have lots of cool information for you about our robot. All right, Max. Well,
okay.
I guess we should probably say goodnight, and unless there's any questions out there, and I can't wait for next week.
That's good. Okay. Well, thanks, Craig, and I'm sure a lot of teams are going to get a lot of use out of this.
All right. Good night, Max. Good night, everybody.
Good night.